at the disk method, there are going to be two important pieces. One of them is what we are rotating, okay? The area or the graph that we're rotating, and that is our solid of revolution. Now, our axis of revolution is the line about which the solid is rotating. And we have a couple different options for that. We have four actually. So we can either rotate it around our x-axis, which was like the first one that I showed you, right? We're going vertically. We can rotate it around our y-axis, which is like the second one I showed you, where we're rotating horizontally. We can also rotate it around a y equals a or x equals b line. Okay. So again, still a vertical or horizontal line. It's just not on my x or y axis this time. Yes. No, maybe. So let's think about if I took a shape and I am rotating it 360 degrees. Yes. Okay. What is my cross section gonna look like? This. They're all going to be circles this time. Okay. So that is the nice thing about our volumes by rotations is that we do not have a bunch of formulas that we have to memorize. Right? We actually should already know our formula. What is the area of a circle? Pi r squared, which is going to be the basis of our rotations. So first let's look at like what some of these might look like. Okay? So what does our graph of x squared look like? The parabola, it specifically has a vertex at 0, 0. Yes? Okay, now on the first one, we're going to rotate around the y-axis. So what would happen if I took that shape and I rotated 360 degrees around my y-axis? What would we end up with? Huh? Like a cone would more be like if you did an absolute value. This is going to be like curved at the bottom, so it is more going to be like a cup-like shape. Goblet. Okay. Now, on the flip side, if I rotated around our x-axis, what type of shape is that going to be? No. So the easiest way I think to think about, again, we're never going to be graded on our pictures, but they're helpful when we're starting to like try and find stuff. Does that make sense? So the easiest way is if I'm rotating 360 degrees, yes? Would we agree that at some point I have to be exactly 180 degrees? Yes? So it will be an exact reflection. So the first, like the easiest way I think is to draw in your reflection, right? And then think about that I am then rotating the rest of that around. So we actually end up with like two horn-like shapes, kind of. Yeah? Okay. What's our graph of the square root of x look like? Pretty sure that was a sound, not a look, but yeah. It is a sideways parabola. Right, half of it. Okay. So if I rotated it around my y-axis this time, again, I'm looking at the exact reflection. And so we kind of end up with a funnel-like shape, almost like a tornado shape. Versus if I rotate it around my again, I get that like bowl-like shape. Yes, no will be. Alright, so then we kind of talked about this next part, but we are looking for the volume of a shape. So let's say that I had some graph right, it doesn't really matter what it looks like, but let's say, okay, it looked like that. Yes? No, maybe? And then I were to rotate that. What are we going to end up with? It is? What kind? Yeah, it looks like kind of like a base, right? Just on its side, yeah. Okay. And again, we talked about how if I were to take a cross section of this, again, because we get our shape by rotating 360 degrees, all of our cross sections are going to look like circles. Which means that if I find the area of that circle, and then I send my number of circles out to infinity, what would I end up with? Huh?
The area of the shape.
Not the area of the shape, but the volume of the shape, right? If I find the area of one slice, send it out to infinity, okay? I'm finding the volume of the entire shape. But, and we said that the area of one of those is what? One circle. I R squared. But again, remember that I drew this like green circle in an arbitrary spot. Yes? So I don't want my R to just be a number, okay? I need it to be the function that I have there. So instead of just like R, we're going to write it as R of X. Okay? Because it's going to be a function of R. Yes, no, maybe. Likewise, like I drew this one. Okay, I drew this one going vertically, yes. Okay, because I was rotating around my x-axis. We just as easily could have rotated it. We get a really funky shape, but I just as easily could have rotated it around our y-axis. Yeah. But now my slices would be going towards my y-axis, which means that we're going to have a function in terms of y. So it just depends on if our axis of rotation is horizontal or vertical. Now, I drew this going to the x-axis, but basically our radius we will always find by going to whatever our axis of rotation is. So we're going to look at an example where my axis of rotation is another line, which means that my radius has to go there instead of all the way to our x-axis. Questions so far? So this says, find the volume of the solid formed by revolving the region about the x-axis from 0 to pi. Do we know what that graph looks like? No, and we're also not expected to. So this would either, one, be a calculator active question, okay, and we'd be able to graph it, or 2, they would give us what the graph looks like. Does that make sense? Because again, we're not graded on our graphs, but we do kind of have to have our graphs in order to be able to set these up correctly. So, this is what our graph looks like. We are rotating around our x-axis. Which means that our full disk is created by going there, which is why then I can create my R, which is what they have drawn, going from my x-axis to the top. Because again, the R stands for the radius, which is why my length this time is only half of that disk. Versus before, remember that our x value or the length, I needed the entire length of what our cross section was. Yes, no, me. Okay, so we're rotating around our x-axis or horizontal line, which means that we are using an equation in terms of x. So now let's think about what would each of my lengths or radii be for that shaded blue region. So I'm just needing the length. So my length should just be a function in and of itself, right? So length, I'm going up and down. Remember, up and down are our y values, yes? So I need the y values for any x value that I have along this spot, yes? Do we have an equation that gives us the y value for any x value along this spot? Yeah, they give it to us. It's our function, okay? Which means that my radius is just going to be my function. So my volume is equal to pi. Usually we just go ahead and write our pi on the outside. Times the integral from, what are our bounds?
0 to pi.
0 to pi of our function. We said that that's our r of x squared dx. So really the biggest parts of these is just going to be finding your r of x. Because then from there, it's just plugging and chugging in our normal integral rules. So what is the square root of sine of x squared? Just sine of x. Well, that's nice because we should know what is the antiderivative of sine of x. Negative cosine of x. And we are evaluating from 0 to pi. Which one do we plug in first? Pi. And then I'm going to subtract off, plugging in 0. Pre-response question. I don't trust y'all's unit circle skills. We are staying there, okay? Now, multiple choice question. We're hoping that we can figure it out enough to be able to choose from a list of multiple choice options. What does cosine start at for its graph? 1. So that means that cosine of 0 is 1, which means on the opposite side, it's going to be negative 1. At pi over 2 and 3 pi over 2, it's 0. So negative 1 minus 1 gives us, times a negative pi just gives us 2 pi. And out there is. What questions do we have on that? So far so good? Alright. Let's look at one where we are not necessarily rotating around our axis. So this time, it says find the volume volume of the solid revolved about the line y equals 1. So I have f of x equals 2 minus x squared, and g of x equals 1. So again, what is it helpful for us to do first? Draw a graph. Now, this time, both of these are things that we should know how to graph. So this is very easily a non-calculator active question. What does the graph of 2 minus x squared look like? Okay. What's the 2 do? So downward parabola would be here. And then what's the 2 do?
Go up.
Yes. So I would be here instead. Yes? Okay. What's the graph of g of x equals 1 look like?
Who's on the line? Who's on the line?
So it looks something like that. We also happen to be rotating around what time? Yeah, so that is my axis of rotation this time. Yes, no, maybe. So on this one, because we kind of have a weird gap, I mean, like, we were rotating around this line, so we would get, right, it's going to be a sphere-like shape, right, just a little bit more pointed towards the top. But I don't really need the full three-dimensional figure. Because remember that my radius is going to go from my axis of rotation out to my finger. So that would be my r of x. Yes, no. What issue do I have this time, though? So, like, is my r just going to be f of x this time? No, because f of x would go from here all the way to here. Yes? What's the issue? Does my r go all the way to there? No. We have this, like, part here that we need to get rid of. Yes? Or, basically, we can think about it. I'm looking for the length between this top graph and this bottom line. How do we find the length or distance between two things? We subtract them. Great, and remember it's top minus bottom. So it would be my r of x is going to equal f of x minus, in this case, g of x. We're okay with that. And g of x could be a curve, it could be a line, it could be whatever. If I'm trying to find the length between those two things, I'm going to subtract them. So in this case, I have 2 minus x squared minus 1. What does that reduce to? 1 minus x squared. Yep. And so now that's my r. So I have pi times the integral of 1 minus x squared quantity squared dx. What do I still have to put on there?
Bounds.
Bounds. What are our bounds? Can they give us bounds this time? So, can I find the bounds? Hopefully so. So, notice that we are going from here to here. Yes? Which also happens to be where our f of x equals our g of x. Yes? So I can set them equal to each other and solve. So notice that I get 1 equals x squared. So x equals plus or minus 1. Alright, then what would we do to integrate that? Well, if I use of that, my u would be 1 minus x squared. What would my du be? Do I have an extra x? No. The 2's not an issue, right? But the x is. Because like before, if I had a 1 minus x quantity squared, then my du was just a negative 1, and we could kind of shoot that over and it wasn't a big deal. Now I don't have enough stuff. So what do I do instead? Clarify what you mean by that.
Like multiplying.
Oil.
Yeah.
Correct, I can do that. As long as we don't mean distribute as in like make both of those squares, because we can't do that, right? I would have to take 1 minus x squared times 1 minus x squared, and we should get 1 minus 2x squared plus x to the dx. Yes, no, maybe so. And then from there we take our antiderivative. I'm going to get x minus 2/3 x cubed plus 1/5 x to the 5th. Yeah, I'm plugging in 1 first and then negative 1. If you do all of that, we should end up with 16 pi over 50. Or again, if it's a free response question, you plug in 1, you plug in negative 1, and you stack, because it has fractions in it. Sometimes if it even doesn't have fractions in it, sometimes all of a sudden 3 minus a negative 1 is 2. So stop while you're ahead. Alright, what questions do we have there? Yes, no, maybe? Ready for one last one? This one is about our y-axis, yeah? So really the only thing that changes is that we need an equation with y in it this time. So what's our graph look like? Cool. With a radius of 4, and we are also confined by what?
X equals 0, y equals 0.
Which is our x and y axis. So that means that really I'm only in the what?
First quadrant.
First quadrant. So we have a quarter circle. And this time we are rotating around our y-axis. So if we do that, what are we going to end up with? The almost semi-sphere, right? Because it's 3-dimensional shape. So it is a semi-sphere. It's like if you cut the Earth in half. Oh, sure. Or, you know, hemisphere. Okay? So, again, remember that our radius is going to go from the graph to the axis of rotation, which is a little bit different this time because our axis of rotation is a y-axis, which means that my length is whatever x equals, yes? Which means that I need an equation with y's in it this time instead. We have an equation, it's just right now it has both x's and y's in it. So what do we need to do?
Solve for x.
Solve for x. So we would subtract y squared and take the square. What do we have to add there? Plus or minus. Which half of our sphere are we dealing with there? Just the positive one. So we're just looking at the positive. And the nice thing is that notice that there's not anything funky going on with this distance. It's just from my y-axis out to my graph, which means that this equation right here is going to be my r of x. Okay, so it's just the distance that my x is, okay, because it's going horizontal. So we have v equals, what comes first?
Pi.
Pi, don't forget your pi. A lot of times on a question question like this for your free response question, one of your points comes from what they call the integrand and the constant, meaning that I just need to have my pi and the correct bounds, and that's usually 1 point. So don't forget your pi, because then you could lose out on kind of a freebie point. What are our bounds in this case? Is it? Why is it 0 to 4? Because remember that my bounds this time need to be in terms of y. Now if we were in terms of x, it's one we would get a different graph. But it would be negative 4 to 4 are our x values, but I have to do my y values. So then we have the square root of 16 minus y squared, quantity squared, dy this time. Mushrooms. Again, we're squaring a square root, so I just end up with the stuff on the inside. What is the antiderivative of 16? 16y minus 1/3 y cubed. And we're going from 0 to 4. So I have pi times 16 times 4 minus 1/3 times 4 cubed minus, what do we get when we plug in 0? 2. 0. That's nice. Free response question? Am I done? Yeah. Now, if this was calculator active or a multiple choice question where the answer was reduced, we would reduce that. And we get 128 over 3 pi. And that's right. So again, really the hardest part of these is choosing what your R is. So we have to be able to draw an accurate enough graph that we can kind of figure out what our stuff is. And that's going to become even more important on Thursday when we're looking at washers, where we're going to have a piece that's being like taken out. Because then we're going to have 2 different R's that we have to find and stuff. Questions on that?